Hey YouTube, Keith here. Today we're going to be exploring the digital side of LED control. This is part 2, or episode 2 of my little series. And what I've got here on the screen is the actual programming code for an Arduino board. So we'll zoom off of that because it's obviously real exciting. Okay, so what we're looking at now is my project board and the Arduino controller with a rotary encoder hooked up to it. I'm going to supply some power to the board. Here we have the LED, and my controller is set to 0. Now as I move the controller clockwise, the values are increased. That's controlled by the software on the board. Increased. And it goes from 0 to 255. It goes from 0 to 255, and we can then also dial back the brightness. 0. This allows us to control the brightness of the LED with pulse width modulation. What the Arduino is doing is it's generating a very high signal, which is sending power out to this MOSFET, which is acting like a gate. Every time pulse is high, or sending out 5 volts, the gate's open, closed, open, closed, open, closed, open, closed. Now the speed at which the pulses arrive and the duration of the pulses. So think of it like 0, 0, 0, 1, 0, 0, 0, 1, 0, I could take the chip off the Arduino and wire it into the board and not deal with any of this hardware. The chip is still a large chip with a lot of power requirements, and I'm not interested in powering that big of a chip or finding that much space in a flashlight body. So the next step is the use of this little guy. This is a microchip. This is a PIC 12F683, and it's also hooked up to a rotary encoder. And as we can see, as I dial the brightness of the LED up with a clockwise movement, the LED glows brighter, and counterclockwise the LED apparently grows more dim. And what's happening is the pulses that turn on the circuit are shorter and farther apart. It's still happening at I think 8,000 hertz, so it's faster than what your eyes can perceive, so you see a dimming. There's no flickering. So let's zoom in on the microchip. And as you can see, that is a whole heck of a lot smaller than what was on the Arduino. Just for a size reference, this right here is correlating to this little chip. Now, the Arduino was a lot easier to deal with. I basically downloaded the free software, installed it, and went to the Arduino website, poked around on the playground for 5 minutes, and found some code I could use. Programming the PIC was a little more difficult, so let me zoom back out and we'll get into that. Alright, so to program the PIC, and this is the little package that it comes in, you can see it's very small. I had to get a PIC programmer, and I chose the PIC 3 from Microchip. It works with the microchip PIC chips, so it was a natural. It does come with a development board, which was kind of nice. There are some lessons you can go through to kind of get a feel for how to program in C. Now the hardest part that I had was installing the development environment, getting all of the software to communicate, and then actually burning to the chip. That was probably about 8 hours of work, because you have to download drivers and download software updates and then find free C compilers and blah 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 blah. The Arduino, up and running with code, powering the light, turning its brightness up and down in 5 minutes. With the PIC, I have absolute control. With the Arduino, I have immediate gratification. So there's kind of a trade-off. So once I had found some code, and I just borrowed code from Cat Macy, I'll put a link to his video here. I used the same chip that he used, and I used the same programming software, which was Boost C from Source Boost. I wanted something that I knew would work, so I duplicated his setup basically. I modified the circuit a bit. I don't need a bunch of fancy stuff. So, to actually program this chip, I had to make a programming bed, and with the Picket 3, it's incredibly simple. All you really need is some wire running from your header to a socket. You plug the Picket 3 in, your USB to the computer, plug your chip in the socket, and program away. Altogether, the Picket 3 kit is about 60 bucks. The Arduino Uno is like 35. So the price difference isn't that great. They're just two cool little things to experiment with. Turn the light away. Now, I don't have everything super stable, but as you can see, I'm turning the dial or the rotary encoder clockwise, which is increasing the value of the pulse width modulation, and the LED is growing brighter in intensity, or it appears to be growing brighter in intensity. Now I turn the knob, or turn the rotary encoder counterclockwise, and the LED appears to be dimming. One thing to note with PWM is I'm using the same power that I would be using if the LED was this bright, or appeared to be this bright. What we're doing is varying the duty cycle. Okay guys, so in the previous video I showed you how a Hall sensor varies the output of an LED using resistance. The way that works is the higher the resistance, the less current, the less resistance, the more current. And that would be the analog means of controlling the LED. Using PWM, what we have is a variable duty cycle. So this sketch here shows an on pulse followed by a short off pulse, on pulse, on, off. Now, in my little sketch here, each full cycle is 4 squares on this graph paper, so this would be a 75% duty cycle. Here we see the LED would only be activated half the time, 2 squares out of 4, 50%, and here 1 square out of 4 for 25%. Now each of these pulses runs at full current, so if you have a LED that changes tint as the current is reduced via more resistance, this might be a good way to go. It's questionable at this low level whether it would really save you anything with efficiency or be more efficient. I definitely think at the higher levels it could be more efficient because you don't need to have 100% duty cycle. I guess that's about it for this episode. I wanted to show you guys how digital PWM works, 2 means to do it on a big Arduino and a little microchip. Alright guys, so that covers it for digital PWM. Future videos we're going to be looking at a couple hybrid solutions, and what I mean by hybrid is a digital control to an analog output. Then we'll hopefully move on to actually building the flashlight. A few more experiments before we get that far. But anyway, thanks for watching guys, and have a good night.